Assalamualaikum warahmatullah and hello to all of you. This is chapter 5, analyzing investment risk and its application. In this video, we are going to look at the measurement of investment risk and its application, interpretation of investment risk, concept of expected return and standard deviation, application in selection fund, how we are going to choose between investment A and B, which one is better, by using expected return, standard deviation, and coefficient of variation as a tool for us to choose the best investment for our client. Okay. Now we are going to look at the first part of the lecture, that is basically on understanding risk and investment volatility. Risk actually exists when the actual rate of return differ from the expected rate of return. Okay, so when risk exists, there is a possibility that the investor will not get the amount of the expected return from the investment. All right, I'll give you an example. Let's say, for example, John, in the case of John, actually need 1,400,000 upon retirement at the age of 55. All right, so as in this case, John need to have 1,400,000 at the age of 55 for the purpose of retirement. And 15 years from now, okay, this is the duration where John can actually save, make a saving for the retirement. That is 15 years from now. Only then John start to retire. At the rate of expected rate of return 7%, by having the lump sum need of 510,000 now, John actually can get 1,400,000 once he reach retirement, another 15 years. Okay, so just by having a cash of 510,000 now, in 15 years it can be increased to 1.4 million. Okay, this is where the expected return is set to be 7%. What if the expected return fall to 6%? If the expected return fall to 6%, John will just be able to get 1.2 million. Okay, 1,222,000, where there is a shortfall of 178,000. Therefore, as in this case, we can see just a very slight difference of the rate of return will actually give an influence to the amount of the investment for the purpose of retirement of John. Alright, now we look at the definition of investment risk. Risk of investment can be defined as variation from expected return. In investment, investors are assumed to be rational in making decisions. Nevertheless, risk still exists, although the investors are rational in their decision-making process. Now we are going to look at the computation of risk and expected return. In this part, we are going to look at how we can calculate expected return, variance, standard deviation, and another one is coefficient of variation. Let's take an example of ABC Unit Trust, where they have the annual rate of return over the last 5 years. Let's say for the year 1, the return is 5%, -1 for the second year, 15% for the third year, 4% for the sixth year, and 21% for the fifth year. When we want to calculate the expected return also means the average of the return. This is very simple, where we just need to add up all of the return and divide with 5. 5 referring to the 5 different years that we have. Therefore, the expected return for this ABC, which is also equivalent to average return, we can see that all of this return add all of them together, divide with 5, we can get 9.2. That is the expected return for this investment. The expected return is actually the measurement of the performance of that particular investment. All right. So next is for us to check on the variation or the variance of the investment, as well as the standard deviation, how we can actually calculate for the variation as well as the standard deviation. All right. By taking the same example of ABC, we can actually calculate, this is the, prepare this column, where the first column is a year past return. For the second column, the third column is actually the average or the expected return that we already calculated before. And now it's time for us to calculate the deviation. Deviation means we have to see the gap between the past return and the average. Therefore, 5 minus 9.2, we can get negative 4.2. Negative 1 minus 9.2, then we can get this figure. So all of these figures are actually the deviation. Alright, so at this point of time, we already have the deviation, individual deviation for each of the year. Now we are going to calculate the variance. This is the individual variance in the sense that we have to we have to take the square of the individual deviation. Okay, so as for in this case 4.2 power of 2, then we can get the variance or the individual variance for each of the year. All right, so if we total up all of this variance together, okay, we can get the sum of 3.304.8, and this is we have to calculate, sorry, we have to divide it with 5 when we want to get the variance for this investment. Okay, so make sure that you are not going to be confused. This is the variance here referring to the individual variance, but once we calculate the variance for the investment, it means that we have to add up all of this figure together and divide with 5, and we can get the variance for this investment is 60.96. Okay, and this is the variance. As in this case, we can see that the variance is 304.8 divided with 5. This is the variance for the investment, and the standard deviation is the square root of the variance. Okay, it is pretty simple. So as in this case, the square root of 60.96 equivalent to 7.8, and this is actually the measurement for risk. All right. Okay, so this is the formula for standard deviation, and this is the formula that we should use if the data is around 5 years. Okay, you can see that number of years is 5. But in the case, if the number of years is higher than 5, let's say 10 years, then we should use another formula where the square root of the variance divided with n minus 1. Okay. All right. So as you can see here, all right, minus 1. Therefore, the variance here, all right, we have to divide it with 5 minus 1 and minus 1. All right, then we can get the new variance. And once we want to get the standard deviation, we have to use the square root of the variance. Okay, then we can get here, this is the square root of variance when the n, okay, or the number of years is considerably, you know, like 10 and above. Okay, at this point of time, we already know how to calculate variance and standard deviation. Now we are going to look at on how we can interpret the standard deviation. Okay, so as we know that the standard deviation is 7.8 as in the first case. All right, what does it mean? It means the larger the standard deviation, the higher the risk. So standard deviation is the measurement for risk. The higher or the larger the standard deviation, the higher the risk. The lower the standard deviation, the lower the risk. And if standard deviation is 0, the risk of investment is deemed to be risk-free. All right. As in the previous example, we can see the number of years of the data is about 5 years. This is a common practice for the unit trust companies to produce or to release the information about the expected rate of return or the past return of 5 years of the company. Nevertheless, in certain situations, there is no historical returns data, no expected returns data. So we still can calculate for the expected return, all right, by using another mechanism, that is by looking at the economics condition. Okay, so how we can use economics condition as a base for us to identify the return? Okay, by looking or by assumption, by setting an assumption that economic condition is good or average or poor, and we can set the probability of happening of 25% of when the economic is good. The probability of happening is 25%, average is about 60%, poor economy is about 15%, then we can also assume the estimated return of that particular investment. After this, by using an assumption to create this table, to create this data, we can calculate for the expected return, variance, as well as the standard deviation. Okay, so if you look at this calculation, expected return, probability times with estimated return. So it is very straightforward. Probability times with a return, and we can get the sum of this for all of the year, then we can get 16.15% of the expected return. The variance, we sum up of the probability times with estimated return minus expected return, power of 2. Okay, so now we know this is the estimated return. So this is the estimated return. This is the expected return of 16.5. We are 16.15, the one that we already calculated before. Okay, this is the probability. Okay, times with estimated return minus with the expected return here that we already calculate here, and we give it a power of 2. We calculate this and we can see the variance is 70.34, and once we get the variance, we can actually calculate the standard deviation just taking the square root of the variance, that is 8.39. All right. Now we are going to look at an example, okay, how we can choose the best investment for our client. Let's say our client want to have the minimum of 5% return per annum. And given that we have two types of investment, let's say bond 1 and bond 2. Okay, so by having this data, it's difficult for us to make the decision which investment we should go for. Therefore, if we calculate the expected return and standard deviation, we can make a better analysis how to choose the best bond for us to invest. Therefore, after we calculate the expected return and standard deviation, we can see that the expected return for bond 2 is higher, which means it's better, and the standard deviation for bond 2 is lower, means that the risk is lower in bond 2. Therefore, as in this case, the decision is of course to invest in bond 2 because the expected return is higher and the standard deviation is lower, which means that the risk for the investment is lower when compared to bond 1. Alright, now we take another example. Let's say you have to decide whether you want to help your client to invest in equity fund 1 or equity fund 2. And in this situation, it seems that your client willing to assume higher level of risk, means that your client is willing to take higher risk. Therefore, let's see if we try to calculate the expected return and standard deviation for us to identify which equity fund we should invest. We can see that the expected return in fund 2 is higher when compared to expected return in fund number 1. The standard deviation, nevertheless, is lower for equity fund 1, but it is higher for equity fund 2, which means equity fund 2 is quite risky in the sense that the expected return is higher than equity fund 1, but in terms of risk, it is far higher than the equity fund 1 because it is 16.52, while for equity fund 1, the standard deviation is just 11.74. Therefore, in this situation, it is hard for us to make decision which fund we should invest. Therefore, what will be the next step we have to do is to calculate what we call it as coefficient of variation. Coefficient of variation is actually defined as risk per unit of return. Okay, we calculate the risk for 1 unit of return. Therefore, how to calculate for coefficient of variation or COV? This is pretty simple, where standard deviation divide with expected return. Okay, standard deviation divide with expected return. This is pretty straightforward. So once you calculate the coefficient of variation, then you can see, alright, for equity fund 1, 0.656233, while for equity fund 2 is 0.87315. Once we calculate the coefficient of variation, how we should interpret for this? We should know that the lower the coefficient of variation, the better. Okay, the lower the coefficient of variation, the better. Therefore, as in this case, we can see equity fund 1 is lower in terms of coefficient of variation when compared to equity fund 2. As in this case, we have to select the equity fund 1 for our investment. Okay, so as you can see, although in the previous analysis, we can see that equity fund 2 is higher in terms of expected return, but once we calculate the coefficient of variation, which is measuring the risk per unit of return, it is favorable. It is more wise to select equity fund 1 once we make a further analysis on the coefficient of variation of the fund 1 and fund 2. Alright, so of course the decision here is to invest in equity fund 1. Alright, that's all for this chapter. Now this is about the tutorial questions. You have been presented with funds that cater for clients with low risk and high risk tolerance in the previous 2 examples. So the following is another set of funds with past 5 years historical return to cater for clients with moderate risk tolerance level. So how would you make your recommendation to your client? Okay, so by having this information, you have to make a further analysis and to make a recommendation of investment for your client. That's all for this video. Assalamualaikum and bye-bye, and have a nice day to all of you.